Today's lesson is on section 10.4, solving trigonometric equations. There is only one learning target in this section, and it is I can solve a trigonometric equation. In order to solve a trigonometric equation, what that means first is to find the value of x. So you may need to use some trigonometric identities in order to simplify the problem, because our goal is to get it so that there's only one trigonometric function within the problem. So sometimes you have to use those identities to switch, say, a sine into a cosine or some other trigonometric function into the main trig function that you're using in the problem. And then since trig functions are periodic, meaning that they do repeat. Remember when we graphed it, we only graphed the first period. That period then did repeat continuously on the right side of the one that you drew and on the left side, meaning that there are many answers that we could get. So instead of finding all of those possible answers, since the sine and the cosine graphs and tangent graphs just keep on going forever, they don't ever stop. To make it a little bit simpler, we just find the answers within that first period, and then because the period is 2 pi for sine and cosine, we add 2 pi n, meaning each additional period, and then for tangent we add pi n for each additional tangent. So let's look at an example of one of these problems where you have to solve a trig function or trig equation. So in this case, it says they want us to solve 2 cosine of x plus 1 equals 0. When solving trig functions like this, what you want to do is get your trig value or your trig function by itself. So what we want to do is subtract the 1 first. So we would have 2 cosine of x equals negative 1. Divide by 2, so cosine of x equals negative 1/2. Now we want to take and look at that unit circle sheet I gave you and look for the value of 1/2. The negative, whether it is positive or negative, tells us the quadrant. So if you think of your all students take calc, cosine would be negative in the second quadrant and the third quadrant. Because cosine is positive in the first, because all of them are positive in the first, then all students take calc. C would be the fourth quadrant, so the only two places it's positive is in the first and the fourth, meaning it's negative in the second and the third. So now we look at our trig sheet and look across cosine for 1/2, and when we do that, we see that it's at pi over 3. So that tells us that our reference angle is pi over 3. So for both of these, the reference angle is going to be pi over 3. So we need to figure out what the full angles are. So in this case, this angle here, then over here, this full angle there. So remember, when it's in the second quadrant, to find that angle, we do pi minus the reference angle. So pi minus pi over 3, which gives us 2 pi over 3. And then remember from the previous page I said because any sine and cosine, we're always going to tack on the plus 2 pi n. So the 2 pi over 3 represents where x is, or where the cosine of x is equal to negative 1/2 in the first period. We want all of them though, so that's why we add the 2 pi n. So now our second answer, when it's in the third quadrant, we do pi plus the reference angle, so pi plus pi over 3. Giving us 4 pi over 3, and then again we want to add on the 2 pi n to represent every answer that's possible within our cosine graph. So we have two answers, 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n. Let's try another example. This one has the tangent in it. So solve 3 minus tangent squared of x equals 0. In the interval, 0 is less than or equal to x, less than or equal to 2 pi. So another difference here between the first problem and this problem is they're giving us that interval, meaning they only want it within that first period. So we go ahead and solve our function. So I'm just going to rewrite it down here. 3 minus the tangent squared of x equals 0. I'm going to subtract the 3 over, so negative tangent squared of x equals negative 3. Divide both sides by a negative, so the tangent squared of x equals a positive 3. And now remember, the tangent squared of x is the same thing as saying the tangent of x, that quantity squared. We just write it on trig functions by the trig function, so it doesn't look like it's just on the x. So in order to solve something like that, we take the square root of both sides. When I do that, on the left side I'm left with just the tangent of x. On the right side, remember, anytime you take a square root, you've got to do plus or minus, so I get plus or minus the square root of 3. So now I need to figure out which quadrant it's in. Because it is tangent, tangents period, remember, is only pi, meaning I'm not even going to look at the second or the third quadrant. Or sorry, the third or the fourth quadrant. So tangent of x is equal to a positive or a negative square root of 3. So if it's a positive square root of 3, it's going to be in the first quadrant. If it's a negative square root of 3, it's going to be in the second quadrant. So if this would have come out to just a plain positive or just negative, we would only have had one answer here. But because it comes out to 2, or because it comes out to a positive or a negative, we have to do both answers here. So now I look at my sheet for the square root of 3, look across tangent for the square root of 3, and I find that that is at pi over 3, so that means my reference angle is pi over 3. So both of these reference angles, pi over 3. So for the first quadrant, it is just that, the pi over 3. For the second quadrant, you define that, which means that you do pi minus pi over 3, giving us 2 pi over 3. And then that is our answers. Because it gives us the interval, we don't have to tack on the plus 2 pi n, or in this case it would be pi n because it's a tangent. You only have to do what is given to you. So if they give you an interval, don't worry about the plus 2 pi n. If they don't give you the interval, that's when you have to tack on the plus 2 pi n or the pi n in the tangents case. So now that we have found excuse me, those first two answers, those are only within the first pi, because remember, tangent has a period of pi. The interval did give us till 2 pi, so we do need to take this problem a step further. Typically on sines and cosines, if it goes till 2 pi, the two answers that you get, you're done. But because this is a tangent, and tangent period stopped at pi, we do need to find the next two in the all the way up to 2 pi. So I do need to think of that, the plus pi n on both of these. It's not part of the answer, but I do need to use that as a reference to find my next answers, or the rest of the answers. So to find the rest of the answers now, you just plug in values for n. So if I plug in a value of n being 0, that's what I got with these first two answers, because that's like then I'm adding nothing to it. If I plug in a value of n being 1, then I'm going to do, for the first answer, pi over 3 plus a pi, which gives us, find a common denominator, which that makes that pi 3 pi over 3, which then gives us 4 pi over 3. 4 pi over 3 is less than 2 pi, so I know that this is an answer. We'll focus on this first one, and then we'll move to the second example, or the second answer. So n equaling 2 would be the next thing I need to do. So pi over 3 plus, then I would add pi times 2, or 2 pi. Find a common denominator, which makes that 2 pi into 6 pi over 3. 6 pi's plus 1 more pi is 7 pi over the 3. And 7 pi over 3 is bigger than 2 pi, which you might have known because you did add a 2 pi. So that means that this is not an answer. Therefore, I don't need to try any more n values because I know everything else past that point is going to be bigger than 2 pi. So now let's go over to our second answer and do the same thing. So if n is 1, then I'm doing 2 pi over 3 plus a pi. So do a common denominator, 3 pi over 3, giving me 5 pi over 3. 5 pi over 3 is less than 2 pi, so that is also an answer. So again, remember, you keep going until you find something over the endpoint, which in this case is 2 pi. So 2 pi over 3, I'm now making n 2, so plus 2 pi. So again, common denominator makes that 2 pi into a 6 pi over 3, giving me 8 pi over 3. 8 pi over 3 is bigger than 2 pi, so that answer doesn't count. So in this case, I do have 4 answers that are between 0 and 2 pi for this problem. Let's try another problem. This problem is a little different because it now has 2 trig values in it, or trig functions in it. The other ones only had the one that you had to solve for. So now whenever there is more than one trig function within your problem, first off you need to make sure that they are the same trig function, which in this case they are, just one is cubed, one is not. But if it was like a sine or tangent within the same problem, then you'd want to convert into all sines, all cosines, or all tangents. But in this case we're good because they are both cosines. And now we need to factor. So anytime there is more than one trig function, you need to factor. So in this case I'm looking at it. I could, if it helps, think of it without the trig function. So it would be the cosine, or 2 times x cubed minus x. And you can think of it that way to help you factor if the trig functions are throwing you off. But in this case, I notice that both terms, both my first term and my second term, have a cosine. So I'm going to factor out a cosine. So I have a cosine of x times the quantity 2 cosine squared of x minus 1. And now once I've done that, now I can set each factor equal to 0. So the cosine of x equals 0, and 2 cosine squared of x minus 1 equals 0. Now they become 2 separate problems like we just solved in the previous 2 examples. So if I focus on the first half, the cosine of x equals 0, it is 0, so it's not a positive or a negative, so I don't have to worry about which quadrant it's in. So I just strictly look at my unit circle sheet, and I see that pi over 2 gives me a cosine of 0, and 3 pi over 2 also does. This doesn't, the general, or the directions, the problem doesn't give me an interval. It says the general solution, meaning that we're now going to have to tack on the plus 2 pi n because it is a cosine. So add 2 pi n to both of these, and that is our answer. Now sometimes some people notice that like these two in particular are only a pi apart, so every pi over 2 plus pi n would work, so sometimes they combine those into one answer, but I'm okay with you listing them as 2 separate answers for now. Now we're going to go ahead and focus on the second part of the problem, so I'm going to add a 1 over, so 2 cosine squared of x equals 1. Divide by 2, so the cosine squared of x equals 1/2. I am squaring it, so we're going to go ahead and take the square root of both sides. So I get the cosine of x equals, now because I took the square root, it's got to be a positive or a negative, because remember, anytime we take the square root, it's got to be positive or negative. And then it's the square root of 1/2, which is the square root of 1, which is 1, over the square root of 2. But now we can't leave a square root of 2 in the denominator, so I multiply the top and the bottom by the square root of 2 and get a positive, negative square root of 2 over 2 for my answer. So now, because it is positive or negative, I've got to find all the places where cosine is positive or negative. So positive, cosine is positive in the first and in the fourth quadrant. Negative, cosine is negative in the second and the third. So for this problem, we actually end up finding an answer in all 4 quadrants because of that plus or minus. So now I need to look at my unit circle sheet to figure out what my reference angle is. So I look across cosine for the square root of 2 over 3, and that tells me that it is pi over 4. So each of these reference angles are pi over 4. So I'm just going to put a reference angle pi over 4 for all of them. So now first quadrant, it is just that angle, so pi over 4. Again, remember there is no interval to go off of, so I have to put on the 2 pi n. And there is another answer, so I'm up to 3 answers on this problem. The next one is actually in the fourth quadrant, because it's like this. So fourth quadrant, I have to do 2 pi minus pi over 4. So 2 pi, if I get a common denominator, is the same thing as 8 pi over 4. Subtract the pi gives me 7 pi over 4 plus the 2 pi n. So there is a fourth answer. Next problem, I need that angle there. So it's in the second quadrant, so I'm going to do pi minus pi over 4, giving me 3 pi over 4 when after I find my common denominator, plus the 2 pi n. And then finally for that last problem, I got to get this whole angle, meaning I'm going to do pi plus the pi, or pi over 4, giving me 5 pi over 4 plus the 2 pi n. Again, there is a way that we could combine some of these, but as long as you can get to this point, that is okay with me. So I actually end up for this problem then getting 6 answers. So let's now look at another problem where you have to do some factoring. So when looking at this, I do have 2 trig functions. Again, remember you need to make them the same trig function. In this problem, they are already both signs, so we're good. So now I just need to factor it. So again, like I mentioned in the last problem, sometimes it's easier to think of this as a simpler problem. So take out that trig function and just put in another variable. So say it's just y, so y squared minus 4y plus 1. So if I gave you that back when we were solving polynomials, what you would do is try to factor it. So you'd look for numbers that multiply to be 1, that add together to be a negative 4. So in this case, that doesn't happen. So since you can't factor, you'd have to use the quadratic. So that's what we're going to do here, is use the quadratic formula. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now keep in mind, if that original one would have factored, we would have factored and it would have made it a lot easier of a problem. But because it doesn't factor, that's why we're using the quadratic formula. So I'm going to plug in my values now. So b, remember, is the coefficient of the plane variable. So in this case, it's a negative 4, so it becomes a positive 4, plus or minus the square root of b again, so negative 4 squared, minus 4 times a, which is 1, times c, which is also 1, all over 2 times a, or 2 times 1. So I end up then, when I start simplifying this, as 4 plus or minus the square root of 16 minus 4 all over 2, or 4 plus or minus the square root of 12 all over 2. So now with these types of problems, when you have to use that quadratic, go ahead and convert them to the decimals. So there's going to be 2 answers here. There's going to be, when you do 4 plus the square root of 12 and then divide that answer by 2, and there's going to be 4 minus the square root of 12, dividing that answer by 2. So when I do the top one, when I do 4 plus the square root of 12 divided by 2, I type that into my calculator, and I see that that comes out to be 3.73. And when I do the minus, so 4 minus the square root of 12 divided by 2, I get 0.27. So now, remember, that's what the y value came out to be, but that's not what it was in my original function. So in a sense, my y value was really the sine of x. So I am saying here, so from here, I'm just going to go up here, the sine of x is equal to the 3.73, or the sine of x is equal to 0.27. So now, oops, that's a bad, let me rewrite that for a minute. 0.27, a little better. Okay, so sine of x is 3.73. So to solve for x, I have to do the inverse sine, so sine to the negative 1 of 3.73. Remember when we first talked about doing the inverse sine? Sine and cosine, the biggest they can be is 1, the smallest is negative 1. So because 3 is bigger than that maximum, there is going to be no sine value or no answer for that part of it, because it is more than 1. It's outside of the range. So now when I come down to the second one, I'm going to do that inverse sine again. So inverse sine of the 0.27. I'm just going to go ahead and type that into my calculator. And when I do that, when I plug it into the calculator, I do get 0.27. So now, in this case, they came out the same. They won't always come out the same. But what that is, remember, is just my reference angle. So now I still need to do the same thing as I've done before. Find when sine is positive. So sine is positive in the first quadrant, and sine is positive in the second quadrant. So that 0.27 is my reference angle for both of these. So the reference angle is the 0.27. So for the first quadrant, it is just that. So 0.27 is my answer. But there is no interval on this, so I have to tack on the 2 plus 2 pi n. So sorry, I'm squeezing it in here. And then for the second one, I've got to do pi minus 0.27. And since it is already a decimal, go ahead and just get the decimal answer to that. And that's 2.87. But again, I don't have an interval, so I've got to tack on the plus 2 pi n. And that would be my second answer then. So sometimes you are going to have to go to decimal. The majority of the cases, like the first three examples, you want to leave them in terms of pi, if at all possible. When doing some of these problems, you're going to come up with what is called an extraneous solution. So you've got to always make sure that you are checking your answers, because remember, an extraneous solution is one that works out algebraically. So when we do the work, we come up with the answer, but when we plug it back in, it doesn't work. So you've got to make sure that on some of these problems that you're checking for those extraneous solutions. So now remember, it's anytime when you introduce a new function to the problem, that's when it could possibly change it. So you'll see that on the next example that we do. So the next example is solve the sine of x minus the cosine of x equals 1 in the interval 0 to 2 pi. So now this is one of those where there is two trig values, so we can't solve it until we get it to where there is only one trig value. So in this case, there's nothing that I can do to switch a plain sine to a cosine or a cosine to a sine. Now, if they were squared, I could do that. Like if it was sine squared, I could change that to 1 minus cosine squared, but they're not squared in this case, so I can't switch them. So what we're going to do is we're actually going to square both sides. And that's what I was talking about when I was talking about the extraneous, is that when you introduce new functions, so this would be one of those cases when I'm now squaring both things, so there's that possibility that I could get an extraneous solution. So now I'm going to go ahead and square that, which means I've got to FOIL out that first side, giving me sine squared of x minus, outside would give me a sine of x times a negative cosine of x, so negative sine x cosine x. Inside would do the same thing, so a negative sine x cosine x, so a negative 2 sine x cosine x would be my middle, and then last would be a negative cosine times a negative cosine, so positive cosine squared of x, and then that still equals 1, because 1 squared is 1. So now to simplify this further, I know that sine squared plus cosine squared, so if I put those two values together, so sine squared and cosine squared, then from my trig sheet, that equals 1. So I'm going to go ahead and put those together, and that equals 1. So I have 1 minus 2 sine of x cosine of x equals 1. So now I'm going to start solving, so I'm going to subtract the 1 over, so negative 2 sine of x cosine of x equals 0. So now that I have it equal to 0, I could, if I wanted to, I could get rid of that negative 2 just to make it a little easier. So I'm going to divide both sides by negative 2. So sine of x cosine of x equals 0 still. And now I have a product that equals 0. So I can take and set both equal to 0. So the sine of x equals 0 and the cosine of x equals 0. And now solve each one separately. So when I do the sine of x equaling 0, I get, when I look at my trig sheet, I get 0 and pi. When I look at my trig sheet or that unit circle sheet and find when the cosine of x equals 0, that's at pi over 2 and 3 pi over 2. Now I can't just circle those and say those are my answers. I do need to check them to make sure that they work. So now to check it, we're going to plug it back into the original function. So over here, I'm going to do my checking. So if I have an x value of 0, I'm going to have the sine of 0 minus the cosine of 0, and I want to know if it equals 1. So when I do the sine of 0, that is 0. Cosine of 0 is 1. So 1 minus 1 is negative 1, so that does not equal 1. So x being 0 is not an answer. Now I plug in pi. So the sine of pi minus the cosine of pi, and I want to know if that equals 1. So sine of pi is 0, minus the cosine of pi is negative 1, so 0 minus a negative 1 is 1, so 1 does equal 1, so pi is an answer. I need to do x being pi over 2, so the sine of pi over 2 minus the cosine of pi over 2, and I want to know if that equals 1. The sine of pi over 2 is 1. The cosine of pi over 2 is 0. So 1 minus 0 is 1, so 1 does equal 1. So pi over 2 does work. So now I need to check the 3 pi over 2. I'm going to do it up here just because I'm out of room down below. So 3 pi over 2. So the sine of 3 pi over 2 minus the cosine of 3 pi over 2. So the sine of 3 pi over 2 is negative 1, minus the cosine of 3 pi over 2 is 0. Negative 1 minus 0 is negative 1. It's not 1. So that means that that doesn't work. So my only two answers are pi and pi over 2. So now when solving these functions, remember our overall goal is to figure out what our x value is. So we're using our some trig identities to get them the same, and then making sure that we do check our answers for any extraneous solutions.